Thank you for joining us. And we're gonna talk a little bit about platforms, not entirely the nitty-gritty technical details of building them, so we can go into a little bit of that if you like. But I think we're gonna mostly talk about why and what to think about when you're deciding what sort of platform to run your software on. So hi, my name is Bridget Krumhout, and some of you may know me from DevOps Days Minneapolis, or from the Minneapolis DevOps Meetup, or the AWS Meetup that we have kind of been delinquent about running lately. And I'm going to, because the projector is behaving a tiny bit differently than I thought, I'm going to just adjust it a tiny bit. We're not fancy, you don't mind, right? There we go. I think maybe we bumped into it somehow. But in any case, I also co-host a podcast called Arrested DevOps, and I work at Pivotal, which is pretty awesome. So we're going to talk a little bit about navigating infrastructure choices, because I've been in ops for a really long time. I recently kind of added it up, and I realized I first went on call for production infrastructure in 1999, and pretty much stayed that way until about 3 months ago. So I still sort of, wake up in a cold sweat wondering where my phone is and wondering if I accidentally left it on silent and wondering if the creepy voice from PagerDuty has left me, some of those. It's like, alert, New Relic, alert on. And it's like, no, that doesn't happen anymore. It's okay. People on Twitter tell me it takes years to get over that particular PTSD, so we'll see. But when making choices about infrastructure, especially if you're in ops, there's kind of a lot of defensive mechanisms there. Like, is this infrastructure going to be performative? Is it going to wake me up in the night? If people are pushing applications to this infrastructure, are they actually going to scale? We've got holidays coming up here. We actually just had Rob Cummings from Nordstrom and Matt Curry from Allstate, but he was previously at PayPal for about 8 years, on Arrested DevOps talking about scaling for the holidays. I think we called the episode "'Tis the Season to be Scaling." But it's like, yes, I've totally been on call on Cyber Monday when we found out the hard way about the global write lock in MongoDB. And this is the sort of stuff that your infrastructure choices and the way you architect your applications and place them on the infrastructure make a lot of difference to people's actual lives. So these are non-trivial decisions that we're making. So let's talk a little bit about platforms. And I'm not actually talking about orbiting space platforms, though those are cool. Also, sidebar, when I read this tweet, I was like, yes, datetime libraries are terrible. Space exploration is just going to make them worse. It's like the Python datetime library already fills me with sadness. It's not going to get any better when we go to Mars. But in any case, like when we're talking about where we're going to run our software, like there's a lot of significant questions around the operational environment that it's going to find itself in. And I think you've probably all seen this, pizza as a service analogy, talking about, hey, we have this entire spectrum from, like IaaS, we're all familiar with, public cloud, to like SaaS. Maybe some of us work for SaaS providers. We certainly all probably use plenty of software as a service. Then there's this whole platform as a service. I think a lot of people think of Heroku. I like to think of it as, if you're building a platform as an operations team for your developers, you're providing a service of a platform that they're pushing code to. If you're a developer working in an organization where your deployment process consists of talk to that ops chick with the pink hair and maybe your code will get to production eventually, like nobody wants that. As friendly or as curmudgeonly as that ops chick might be, like that's not the processes you want. We want everything to be faster, cheaper, safer, and more self-service. I work for Andrew Clay Schaefer. If you came to DevOps Days Minneapolis last year, you would have seen him as our closing keynote speaker. And he tweeted what I thought that was this really interesting infographic to kind of help people imagine this distinction between a more structured or opinionated platform all the way to a completely unopinionated one. Everything from, buy a complete treehouse to 2x4s. What I thought was, this spurred a really interesting discussion on Twitter. And Kelsey Hightower came in and said, well, Kubernetes isn't really like 2x4s. It's more like there's 10 different ladders. And I'm like, you're making his point for him. Which is to say that building platforms is, I'm here to tell you, a lot of fun. It also is possibly not the place that you should spend all your innovation tokens. Like it's possibly not the place you're going to add the most value to your organization by saying, we have a really innovative and exciting infrastructure. It's like, okay, that's cool. Like, cool user story, bro, as my coworker's Casey's t-shirt says. But that's not necessarily where you're going to add the most value. So I did work at a place where I was building a platform. Some of you may have seen me talk about this before. And I was working at a startup that was a streaming video site. It was very much like Netflix, if Netflix were much smaller and mostly Korean soap opera and ran Docker in production. So, you know, not exactly like Netflix, but it was a very interesting learning experience because building out a platform based on, you know, some super hyped, trendy software choices is a lot of fun, also a lot of work. Also, it's not like the stuff is actually ready for prime time right out of the box. So this is like that whole, it's like you build it because you need to. The reason that we needed it at Drama Fever actually was because back in 2013, Drama Fever, it had been around, you know, for about 2-3 years already by that point. And by 2013, it had a giant monolithic Django Python application. And with all of the attendant problems that you would imagine in a monolithic application, which is to say, if you wanted to make changes, if you wanted to ship, you know, a new feature, there were a million things it could touch and a million things it could break. So starting to decompose those into Go microservices, which of course were faster to make changes to, and a little bit, you know, easier to develop. And there's also, of course, there's resume-driven development. It's a lot easier to hire developers in 2013 if you can tell them, you can spend some of your time writing microservices in Go. And they're like, buzzword, buzzword, yes. And so, like, getting people to actually write the microservices, not so hard. Getting those microservices out to production, a little bit harder, right? Because the way Drama Fever was doing deployments, when choosing to replace the large scale with the small scale, the way the deployments were actually working was a Git checkout and baking an Amazon machine image. This works just fine with Python. For some values of fine, as long as GitHub isn't having any problems. You start to see the problem when you're trying to do something that's not just, you know, like run some Python, drop it in this directory, but actually building a Go binary. Oh, okay, so now we can't just do a checkout from Git. And by the way, sidebar about this whole microservices, you know, are too complex. There was a very interesting rebuttal to this at Recon, the Basho Distributed Systems Conference, from Adrian Cockcroft of Netflix fame last week, where he pointed out that monoliths still have complexity. You just have no idea where it is. So it's like, we can joke about how hilarious it is that, you know, microservices cause us, you know, like every outage is like a murder mystery. Yeah, I mean, if your instrumentation isn't set up very well, absolutely, but like monoliths have their own complexity as well. And another sidebar about that, by the way, like I got my computer science degree in the 90s, which means I learned Scheme, which is basically Lisp, which means I have a lot of parentheses in my head at all times. So if there's a lot of digressions here, it's because I'm doing this car, sort of thing. I see some people as old as me laughing. It's like they probably learned Scheme too. But that thing about microservices versus monolith feeds directly into Conway's Law, right? And I think that one of the cultural challenges at my last job at Drama Fever that we had with this is we still had a very monolith-style organization, but we wanted to do microservices. But if you don't want to break your teams down according to how much pizza you want to eat or whatever dogmatic Netflix thing that you're supposed to choose, if you don't deconstruct and reconstruct your teams in a different way, or at least have them cooperate with each other in a different way, it does make the API handshakes between the different parts of your infrastructure are going to be influenced by the fact that the different parts of your organization may or may not be talking to one another at any given time. So sidebar there, I think it's a little interesting just because what Mel Conway said, and I assume everyone's probably familiar with Conway's Law, but if you're not, this is from a paper called How Committees Invent, or something along those lines, from 1967. So he was writing about microservices before they were cool. But anyway, back to the deployment process at Drama Fever. It did not work to keep deploying from GitHub. Like this did not work. So they needed a different way. And what they came up with was, hey, if we have our build server actually package a version deployable artifact, we can do that at least for Go. They ended up going with Docker for this. And this was really early for Docker. And yes, that is the Vasa. And yes, if you haven't watched Pete Cheslock's talk, 17th Century Shipbuilding and Your Failed Software Project, you should definitely watch that. It's a 5-minute talk from Monodrama in 2014, and hilarious. But the idea of going to Docker in production in 2013 like sounds completely deranged, but it was probably fine because the underlying concept of containers is not actually that new. And if right now you're like, okay, containers, what? I thought we were going to talk about products. This is a product track, right? Okay, so if you're not super familiar with containers, the TLDR is, you know how when you like go to your Windows machine and you try to upgrade something and there's DLL hell and everything is terrible, and you're like, why am I using Windows anyway? It's 2015. But then on the other hand, if you upgrade an app on your phone, it comes with everything that it needs. And you don't spend any time worrying about external dependencies. That's what containers bring you, but like, you know, out on the internet. So it's much, much better. And that, going to that sort of packaging of our software for deployment made it much easier. And so having Jenkins do the containerized builds, whether it was, there's a couple of different ways to do this. So like usually, obviously, your CI system is going to be running your tests, but we also had the CI system run tests, then if successful, like first build an image with either just the Python code in it, or build an image with the Go binary, run some tests. If successful, ship that image, saying this is the image that can run the Python Django app, or take the binary for the Go image and put that into a much smaller image, because you don't need to ship all of the tools that you need for compilation if you have a statically linked binary. So they made it possible to ship much, much smaller Docker images to speed up the way we were doing our auto-scaling. Of course, the version deployable artifact thing is like, you know, a giant win. But there's also this thing about a standardized development environment. So a lot of people think of, you know, containerization or Docker as being something that you use for dev. But you do not want to have a dev do Docker build on their laptop and then YOLO that shit out into production. Like, that's just not going to go well. Because you're like, what do we have running in production? I wonder. I don't know. Sure wish I knew what happened in that Docker file on that person's laptop that they didn't check into GitHub. So it's like, what you actually want is your CI system creating any artifacts that are going to go out into production. I mean, even if they're Docker. But there's nothing that stops a developer from doing a Docker pull and pulling those, you know, speculative dev build images that are being built by the CI system all the time, pulling those down and doing a Docker run in an environment that's going to be the same as what all their coworkers are using. So that's kind of like, again, that's the idea of when you're deciding what kind of constraints you want, letting everyone do everything that they want is super and probably a terrible way to build software. It's a great way to make people happy, for some values of happy, until they actually have to interoperate. Putting a certain amount of constraints around people, like, and this is the images that, you know, this is the path your code will take if you actually want it to get to production, or these are the images that we're all going to agree are what we consider to be, you know, the real dev right now, like, buys a lot. And not that this is not a you should use Jenkins talk, because there's an open source CI tool called Concourse that folks at Pivotal have been building and open sourcing that is actually really cool. If you try to do a lot of complex pipelining, you might want to look at Concourse, just because pipelines are first-class citizens. And so the kind of trouble you can run into with chaining your builds in Jenkins, where you're like, what do you mean I can't do another post-build action? Like, you can solve that with something like Concourse. But really, this is kind of one of those, like, taking a step back from the tools. I don't really care which one you use. Like, it doesn't matter. Just use something, because you're never going to get your software to production, like, you know, consistently and correctly and safely, unless you're using something like this, right? I mean, everybody here knows that. Also, I feel like as an ops person, I've spent a lot of time thinking about how deployments should go. And again, these are details of your platform, details of your infrastructure that they may not be the thing that your management is excited about. Like, unless you have, you know, very specific subset of the managers out there in the world, or the C-suite is not usually going to be super excited about your zero downtime blue-green deployments. They'll be really excited about the fact that you made more money, or they'll be really excited about the fact that you got more eyeballs or that you got more visibility. So, like, I think as a practitioner, we spend a lot of time focusing on details that aren't necessarily what is the actual business value here? Like, the actual business value is what we have to put a little bit more thought into. And on this topic of deployments, like, one thing that we were doing at Drama Fever was these, you know, canary deployments, where we would get something out there that was not hitting the entire infrastructure. Because we were using pretty much an artisanal bespoke platform that we were building as we went, we did not have a really good way to have our canary infrastructure be the exact same as the rest of the infrastructure that we were treating as disposable and ephemeral. So like that canary kind of ended up being a special snowflake. It was a little bit of a problem that we tried to solve by, of course, being practitioners, bolting on more automation. So we were like, all right, we're already dockering all the Dockers, let's add some Chef. And the problem with like adding more tools when you're trying to solve a problem is that you certainly can. Like you always can add more tools. But the benefit that you're gonna get from adding more tools, even if they're your favorite, sometimes is outweighed by the drawbacks of the increased complexity and the increased surface area for failure, for confusion, for lack of collaboration across team that you can get from doing that. So it was definitely like kind of a mixed success in terms of like adding more automation in this particular case. This is Schaefer, my boss at Pivotal. I went to go work for Pivotal because I'm friends with this dude and he's hilarious. But he has this really good point when he says that, okay, the things in your infrastructure, in your organization, the things that are not working at all, okay, there's a giant failure there, you will fix it. The things that are terrible but you're just living with because they're temporary, because you set them up hoping that you would change them next sprint. Or the things that you did in a hurry, like a couple of jobs ago, I worked someplace where our CEO did a webinar. You should never let them do that. Our CEO did a webinar, and the 2 sprints after that were implement everything the CEO says we do, parts 1, and then part 2. That was like the solid month after that webinar was cleaning up after that. And it's like, all of the things that we built in that, in those 2-week sprints were terrible. And they were all emergency basis, and until that startup got acquired, they all stayed in production. So this is your warning. It's like not that you should let the perfect be the enemy of the good, but it's going to whatever you choose is probably going to stick around. So again, these choices do matter. Another sidebar, like I feel like it's really easy when you're trying to plot out. Okay, so say you have this roadmap for improving your infrastructure, and you're trying to plot out where do we start. And what are the obstacles along the way going to be? It's really easy to focus on semi-irrelevant details. Like, for example, if I were trying to ride my bike to Pivotal San Francisco offices, Google Maps wants me to know that there will be a ferry on this route. I'm like, okay. So yeah, somewhere way near the end of this route, I'm going to take, the Alameda Ferry. That's fine. I think the part where there's, 8,597 feet elevation change might matter a little bit more. But we don't get a giant exclamation point from Google for that. And I feel like that's when we're trying to make, to map out how are we going to make improvements to our organizations, improvements to our software infrastructure. Like it's really easy to focus on this one giant thing at the end and not all of the plotting incremental, smaller yet very significant things we have to do along the way. And so I kind of want to shine a light on that and make sure we're thinking about it. Because I don't know about you, but I know that I totally go and run a Markov bot against the front page of Hacker News when I want to make technology decisions, right? You do that too, right? Yeah, no. So it's when you're trying to decide what to use, deciding that you definitely want to get some of that Kubernetes and maybe some of that Mesos because you hear that that's a thing, and you're not sure if you're supposed to use them together or separately, or maybe one on top of the other, or maybe use one first and then realize it's not working for you and switch to the second. That's how a lot of these technology decisions go. And I think that I've totally done this. I've totally worked at the startup where we had, MongoDB and HBase talking to each other because why not? And I'm here to tell you that just because you can, again, does not mean you should. So a little bit more structure in how you're building these stuff goes a long way. Because, again, making these decisions, a lot of it does come down to what are the people I respect doing? What are the people who I can ask questions of doing? If there's a vibrant community around something, hey, maybe that's a sign that if I try it, I'm not going to be SOL and totally on my own trying to read really sad questions on Stack Overflow from 8 years ago that nobody has answered. And you're like, what did you see? Like the XKCD. It's like, but at the same time, just because, the cool kids TM are doing it does not mean that we should cargo cult it. And if you want a counterexample, look no farther than Etsy. They use no cloud, almost no VMs, and they don't really call it DevOps. and yet their DevOpsing is highly successful. So, and they're not even Dockering any Dockers. So,
which company was that?
that was Etsy.
Oh.
Yeah, they have a world-class engineering organization and not a Docker to be seen. So totally possible. Something else to keep in mind is like, I think that there's in this DevOps discussion, there's kind of this like divide between operations and developers, where as ops people we think, well, those developers are just going to ship us a bunch of bugs. And if we don't have to deploy their changes to production, maybe things won't be as terrible. And it's like, you know what? Okay, first of all, you should be writing your infrastructure as code. You should be, what version is your infrastructure? There was a great blog post called that a while ago. And if you have no way to say what version your infrastructure is, like, please go home and commit all of your sudoers files and all of your chef and all of your config files and the configs from your routers and everything else. Oh yeah, and all of the contents of all of the JSON that describes your Amazon environment, please go commit all of that to source control. Like, oh wait, just go home and do that. We can pause here, we can get some more coffee. Because like the infrastructure code that you write, like even if it's janky bash, and God knows I've written plenty of janky bash recently, but even if it's janky bash, it does matter. It is powering your business. Like this stuff is valuable and is just needs to be captured in version just as much as the features that your company is shipping. And like in terms of defining and capturing this, like this again is where there's a lot of well-trodden paths and there's a lot of reasonably well-established patterns that high-performing organizations have been using for years. So I'm not saying that you should use any one specific one, but I'm saying that instead of inventing it all from scratch, looking at something like, say, Bosch for your low-level cloud agnostic infrastructure automation, talking to your IaaS layer. Because, I mean, if you're launching everything in Amazon by going to the GUI and clicking on it, and then hoping that next time somebody wants to do something, they'll go to the GUI and click on it maybe the same way, like that's just gonna lead to sadness. So using something around your automation for that, whether it's, Packer or Terraform or, whatever, is like super important. I think that when we're trying to like create this kind of visibility, like it's sort of I think it's sometimes a humbling experience for people who have been doing all of the platform ops and maybe working with the data center or maybe are the only ones who have the prod AWS access keys, that other people in the org maybe don't know what you're doing. And like shining a light on that, creating the visibility into what you're doing helps you, even if you're solo ops. I spent 2 years at a startup here in Minneapolis as a one-woman ops team. But having everything in GitHub meant that I could go to the Boundary Waters. I could go to Split Rock Lighthouse. I could go to Duluth. I could turn my phone off, and the devs could take care of it. And granted, this means that we used a little bit more of the AWS training wheel stuff than I otherwise would have. Like, for example, running Hadoop clusters on EMR, on Amazon's, training wheels for, MapReduce, instead of like running them yourself from scratch or from like a distro that you would have preferred. There are trade-offs there, but making more space for other people to understand this stuff is worth it. We talked a little bit in the fishbowl about architecting for failure. And I think that like what's really important about that is remembering that it is okay if something fails. Because if you think of it this way, AWS spends billions of dollars on their infrastructure and they still have outages. Like you're going to have outages because you're probably not spending the billions that AWS does. And so instead of just saying, I really hope nothing ever goes wrong and that's your plan, it's like, just plan, things will go wrong. How are we going to react when they do? I mentioned Etsy before, and they have a really strong culture of blameless postmortems that they talk about that I think is really valuable. Like, establish that early in your organization that we're not going to blame you or fire you if something goes wrong, but you need to tell us what happened, and you're going to get much better results. And then the other thing about that is the idea of distributing decision making. And like if you've ever experienced well, we can't decide that until California wakes up, and you're like, that's great because they don't go to work at 8 a.m., so it's going to be hours. Like that's not a way to run an organization, and most of our organizations today do have some component of that. And so like, just like in our distributed systems, it doesn't make any sense to say we are going to just set a lock. It's like back to MongoDB and like the global write lock that it used to have. It wasn't, by the way, it wasn't just a write lock, it was a rewrite lock. So if you needed to read assets out of that same database that you were trying to write your sessions to good luck. But if you're trying to keep on top of our highly disparate world, it makes a lot of sense to distribute as much decision making to the edges as possible. This part of tech is something that I actually think that, again, and it's highly relevant to how we architect our infrastructure, because people get upset if they feel like you're cutting them out of the decisions, or if they feel like, say the developers feel like, the ops team or platform or whomever is not going to let them do what they want. And the question is not, oh, how can we just make you happy and let you do whatever you want, but what do you need? What do you feel like you're being blocked on? If you can ferret out what somebody really feels like they're being blocked on, maybe they feel like when they want to deploy a change, they have to wait too long because it affects other things. Okay, let's talk about microservices. Maybe they feel like they want a little bit more of a self-service deployment model. Okay, then you have to build something into your platform, whether it's how the authentication works so that it doesn't require that master AWS key in order to deploy something, or it doesn't require the ability to tear down and stand up new instances. Again, if you can go with something that allows you to do application container clustering, you don't have to be able to create and destroy instances in order to scale or in order to roll out something blue-green. Astrid Atkinson is a director of search at Google. She's been at Google for a decade. She had a really good keynote at Velocity Santa Clara this past year that I think everyone should go watch. It's called Engineering for the Long Game. And what she talks about is that Google didn't sit there 10 years ago and say, hey, in 10 years, we're gonna be Skynet. They didn't know any of that. But how Google actually got to where they are now is by looking ahead, looking ahead 6 months, looking ahead 12 to 18 months, and just trying to incrementally improve. So, and that does include paying attention to all of the human beings in the mix. We're not just designing systems for the computers to talk to each other. We're all still here too. I think that we talked a little bit about this in the fishbowl too. This idea of how we pass information around. And I think that building a little bit more structure into our automation can help with that, so that you don't have to have this external source of a person telling you that this is how these particular logs work. Or, oh, don't you know, you didn't log in this specific way. Say, we do a lot of talk about 12-factor app, but I think that you need to have that, you have to complete that handshake with the idea of 12-factor ops. For example, if a developer logs in the expected way, well, there sure as heck better be something there that's going to collect the logs and make them visible in an appropriate amount of time. And just dropping them in an S3 bucket probably won't do. But again, then you have to build something, or build or procure something in your infrastructure that's actually going to do that. Because oral tradition, while fun, is basically the equivalent of keeping everything in RAM all the time and never writing anything to disk. We wouldn't run our systems that way. We should not run our organizations that way. I have a coworker of mine, Casey, wrote a really good blog post about durable communication. Before he worked at Pivotal, when he worked for a security firm where he was running 3 teams remotely. And what he stresses is that if we make sure that we're capturing the information that we're imparting in a more durable way, instead of just writing that GitHub commit that says fixed, really? Because that doesn't help your coworkers. That doesn't help you in 6 months when you're wondering why the hell you did this. You're like, deserialization of Java, what? It's when you're trying to solve these problems, the more durable communication, the better. And it also means that that person who needed to go, pick up their sick parent, or take their, go to their kid's school conference, or, was on a plane at the time, is also included. So there's a lot to be said for making the choices to be, even though we make a big deal in the Agile world about working together in person, fast feedback loops, and that is important. And I'm not saying we should go to the world of file a ticket and wait, because I lived in that world. I'm sure some of you lived in that world. It was terrible. We don't want to go back. But we should not neglect writing things down, because it does help people a lot. When we're talking about our platforms and kind of just taking a step back and thinking about what promises does your platform make, and what promises can your platform keep? This idea of, if someone deploys something, an application in the expected way, can it scale? I mean, hopefully, like hopefully, say your app becomes very popular, hopefully it's not going to fall over as soon as like, you know, all the people in this room go and hit that application. Or if, for example, if you have failure in your system, like what's the failure state going to look like? If your application developer may not architect something in, you know, exactly into the application as to what the failover checkpointing and recovery will look like, especially if they can rely on the platform to provide that for them. So there's also this idea of reasonable constraints, and this is back to the idea of we all would love to just do whatever we want, except that nothing would work then. On the other hand, we don't want to live in this like super rigid ITIL world where we can only fill out the 42-page change management form and then wait a couple weeks for the change control review board. And that, I'm pretty sure the statute of limitations is expired on when I worked at Quest, because it's not even Quest anymore. So I'll just tell you now that as it turns out, everything was an emergency because the emergency change process was so much easier. So I just filed an emergency ticket every time. It worked for like 2.5 years. So, but like if we want people to actually work within the constraints, they have to be reasonable constraints. So reasonable constraints we can all agree on are something that I would, you know, strongly recommend. And like to this question of a platform, the 18F folks, so if you're not familiar with them, this is part of the US Digital Services that is like working mostly on new projects, kind of greenfield stuff. But this is related to the, you know, the whole like rescue of healthcare.gov and then maybe bringing some modern IT into government. 18F has decided to build a platform for government applications. They're actually building it on open source Cloud Foundry, so this is not a product pitch. I do work for Pivotal. Pivotal does develop, and Pivotal actually employs about 150 developers to write open source Cloud Foundry, like full time. Because again, like if you want to contribute to a community, it's important to make sure people don't have to just do this on weekends and in their spare time. Like they should be writing open source code and being paid for it. Like that's how you make people's lives better. But anyways, Pivotal does have a commercial version, but 18F is not using that, and we're perfectly happy that they're using open source Cloud Foundry, because I think it says a lot about the kind of constraints that good software can offer and provide. Is that the U.S. Digital Services 18F is now running cloud.gov. You can go check it out. You can, if you're not with the government, I don't think you can actually use it, but you can go read their documentation. They've written for it, which is quite good. And just look at the fact that this is making it so much easier for developers of applications that are meant to do things like, you know, assist with voter registration or whatever, or you know, getting veterans their benefits or that sort of thing. Like everyone who's going to develop an app for any of these purposes doesn't have to set up the logging and monitoring and metrics and health checking and scaling and remediation of failure and you know how it talks, you know, what all the infrastructure hooks are, and you know, setting up the auto scaling. Like these are a whole lot of things that, like, if you imagine every application developer having to do, does not make any sense. So, like the idea behind in your organizations, if you're thinking about, well, this particular kind of project, we deploy it this way. This one, I mean, that's over on App Engine, totally different. This one, we've got a lot of vSphere because, you know, we're doing a lot of things that start with V because there's V experts involved or something. Like, if you think about all of the duplication of effort that you may have in that kind of environment, it makes a lot of sense to make something a little bit more structured that, again, you still listen to people, take their input, make sure that people have what they need so that they want to use it. Nobody wants to be told, you have to use this new thing and it's terrible. Like, no one wants that. But if someone can have, you know, the Heroku-like experience, like with Cloud Foundry, they literally CF push their application, and it just runs. And it's like, that's the kind of building, like something like that, as close as you can approximate something like that. And we had, you know, something similar at Drama Fever where we were making the promise to the developers, if you check your code in and it's on this branch, and it passes all the tests in Jenkins and it builds and pushes, like it will run in production. You don't have to worry about any of this. Like putting that sort of handshake in the contract between operators and developers, I think, goes a long way towards making sure that we can all work together to build something that's actually going to function. So, and I really like this quote from this Brett from 18F, where he pointed out, like, okay, if we know we're going to ship code again and again and again and again, we may as well have a standing environment that we could do it from, instead of building that bespoke, hand-whittled every single time. So, platforms, think about it. And yeah, that's my talk. Thank you very much. I don't know how we're doing on time. If we can do questions.
We have lots of time left.
We have lots of time. Great. It's funny, I
made a mistake in calculations.
Oh, goodness. Yeah, I saw the 15-minute one go up, and I thought, well, that was earlier than I thought. But excellent. That means we have a lot of time. Excellent. I can hear from you as to what you folks are doing, building, shipping. Actually, what I would love to know, since I didn't poll people at the beginning, is I have no idea who I'm talking to. So some of you, I might have said Docker, and you're like, yes, I'm wearing Dockers. They're delightful. Like, do a lot of people in this room consider themselves like software developers or like project managers, like system operators? Okay, I have no idea what you do. So shout it out. Like, what do you folks actually do? Name some job titles. Let's hear them.
Engineer manager, development lead.
Yeah, yep.
Developer.
Sorry?
Developer.
Developer, okay.
Scrum Master.
Uh-huh.
Scrum Master, automation engineer.
Yeah. Okay. So I feel like, yes.
Bridget, I
Yes.
have a question. It sounds like you continuously separate development and DevOps,
Mhm.
instead of converging together and making every Scrum team having its own DevOps team. For example, we built the cloud. We had a huge safe running 60 Scrum teams, multiple trains, but we rely on full automation powered by your team, of course. CI, CD, and like that. So is that a kind of strategic direction, like when we're talking about SC, cloud, gov, they're taking, or they still kind of separate?
Okay, if I understand the question correctly, I'm being asked about whether I'm drawing a distinction between development and DevOps. And DevOps is a cultural practice of practitioners across disciplines inside an IT organization working together to improve their organization and their communication. So some people put DevOps in titles or say that they have a DevOps team. And I at one point I might have scoffed at that, and at this point, I mean, I don't care, it's fine. But like, I think that instead of saying like, these are the DevOps people and they do the DevOps, it makes more sense to say we're all going to cooperate and collaborate to make sure our DevOps practices in our organization work well. Whether someone is specifically tasked with primarily shipping features or primarily site reliability. And sometimes you have like, full stack engineers who are tasked with all of the above. But I challenge you to find someone who really wants to spend all their time writing Terraform scripts to automate AWS and also writing Angular. Like, it's possible, but a lot of people have something they prefer to spend most of their time on, and that's fine. Like, I disagree with Heinlein. I don't think specialization is for insects. Like, I think it's okay to have something you enjoy doing and spend a lot of your time doing it, as long as you don't ignore all of the needs of the rest of the organization. I don't know if that answers your question, but okay. All right. Since apparently we're still running early, let's hear from more people. Yes?
So you mentioned the canary analysis, testing. Can you go more deeply into that, particularly in the testing environments, how you do the canary in the testing?
Yeah, so when I'm talking about canary, I'm specifically talking about production environments.
Okay.
Just because in a test environment, I mean, if it's a test environment, then by definition, you can do whatever you want in it because it's a test environment. So, but what I mean by canary is that instead it's this idea of like the canary in the coal mine, that like if you put the canary down there and the canary keels over, maybe you don't want to put some miners down there until like the dangerous fumes clear. So for a production environment, instead of like a big bang release, well, that's probably not the right phrase because that means like larger changes, and I don't want to conflate small batch size versus canary deployments. But when you have a production release of code that you want to put out, no matter how often it is you're putting it out, if you put it on all of your infrastructure at once, then you're not going to have any opportunity to back out gracefully if you find that something unexpected is happening. So it usually makes sense to have, like, say, start with a small percentage of your instances or your endpoints that have the new release of code. There are a lot of, as you're, of course, probably well aware, there are a lot of technical implications that matter here. Like, for example, if you have schema changes with your database, they need to be forward and backward compatible on a release by release basis, because, and this makes sense anyway, just because your releases necessarily across a larger distributed system are not going to be entirely atomic. So it's not like you can guarantee that absolutely every instance is going to upgrade to the new version of the, the API or whatever or the new version of the code at the exact same moment anyway. So your backend data stores need to be able to accept traffic from the old and the new. But in the case of your Canary release, it makes a lot of sense to have, and again, you can do this through a lot of manual or different kinds of scripts around it. It's obviously helpful if it's built into your platform, but having like a smaller percentage of your traffic going to the new code, and then having a dial where you can ramp that up, and then if it's not going well, ramp it way back down, is what I mean by that. I don't know if that answers your question, or if you want to talk more about the technical specifics of it, or?
Yeah, so we're just implementing this microservices
Sure.
system. So we have some conversations of, sometimes if you don't have traffic, how do you simulate that traffic in a testing environment to do the canary, for example?
I see what you're saying. So what I would recommend doing to simulate production traffic in a safe environment is if you can do something to mirror your production traffic, so like to capture and replay it. And again, there is tooling out there to do this, but basically you're right. You can't really simulate what your production traffic patterns are going to look like, but you can, for example, take that production traffic and also pass it to something that's not actually going to do any writes, and it's just getting like a copy of any, like reads or other such accesses that are non-destructive access. So I would say that's different than simulated load testing. So, I mean, because there's like the New Star folks, and there's a bunch of other SaaS services that'll do like real user, simulated load testing, and you can kind of write a whole script and say, this is what we wanted to test, these are all the points we wanted to hit. But if you can mirror your production traffic, obviously minus any of the destructive operations, that's usually the best way to see. I wouldn't even call that a test environment. I would call that kind of like a pre-production, like smoke testing sort of, staging-ish environment is like anything you can do to shoot some production traffic there after it's done its real work on the actual data store is what I would recommend for that. That's what we've done, at least with some success. So, hey, yes?
I have a question. So, going back to the idea of testing, like when you're deploying an application and you're focusing mostly on the front end and gathering data back about how things are performing and iteratively improving the front end experience, what's the best way or frameworks that you found or tool sets that can be used to do that in a way that actually works more like what a unit test in the back end would look like, where you're actually getting data that informs the decisions about how you improve the code base on the front end?
So the question is about, if I'm going to try to paraphrase this, it's about the real user experience and testing from the front end to simulate like the kind of information you would get from unit testing in the back end. I think it's possible to. There are a number of SaaS services out there that offer this kind of real user testing. What I've seen people build if they want to build something in-house, and again, the folks at Etsy have done some great work with this, but I've seen people build like front-end testing rigs, whether it's through Selenium or something else. I'm not sure that I'm really the right person to go into a great amount of detail on that. I would love, however, though, if you ask me that on Twitter, I would love to connect you to some of the folks that I know who do a lot of really great front-end testing. One of the conference chairs of Velocity, actually, Steve Souders, is super into web performance and works at I think it's called SpeedCurve, is a startup that looks into exactly that. So I'd love to connect you to people like that, but I'm not an expert in that myself.
Also depends on your dev environment. If you're using JavaScript,
Also when you're talking about single page apps, that's an entirely different beast. There's, I would refer you to, there were a couple of really good talks at Velocity, specifically Velocity New York this year. Velocity Santa Clara had a couple too, but Velocity New York had what looked to be, again, this is not my area at all, but it looked to be some really good talks about speed and performance in single-page apps. So I would say check that. Like velocityconf.com has a lot of videos from like the keynotes and whatnot.
Awesome, thank you.
Yes.
Have you used anything in like containerization to help speed up developer setup as well? So not just deployment to prod, but so developers have a development environment that's fairly prod-like, has whatever we need for certificates and/or version.
Yeah, absolutely. The question was about using containerization to speed up the provisioning of a developer environment. And that is exactly what we did at Drama Fever. I alluded to it briefly, but I didn't go into enough detail to really be replicable. So let me go into a little bit more detail, which is to say, because we were using Docker across the, the entire request path in production and all staging and test, and dev, but also on local environments. At the time, we were using something called Boot to Docker. It's since been replaced by something called Docker Toolbox. And Docker Toolbox runs on Macs, I think Windows, probably, I don't know. If you're making developers use Windows, I'm sorry. So it runs on Macs, by your developers' Macs. Or, obviously you can run Docker natively on Linux. And what that allows is for the developers to do a Docker pull from your private repo, because please tell me you have a private repo. I mean, especially because Amazon actually provides like private Docker registries, and Docker Hub provides them now. Like, we had to roll our own, back in the day when we had to walk uphill both ways through the snow to get our, like private Docker images. We actually ran a host local registry. Like we ran the registry container on every instance and on people's laptops, and then had it all back into the same S3 bucket. And the credentials that we used to talk to that S3 bucket, we used different ones for the Jenkins server, so only Jenkins could do a Docker push to that registry, because we didn't want to, have somebody be like, Docker build, Docker push while they're drunk or whatever, and then suddenly everything is sad. Like, nobody wants that. But yeah, so new developers starting at Drama Fever would be able to run a couple of, there were a couple of, janky bash scripts, because admit it, you've got them. There were a couple of shell scripts that I wrote and a few other people wrote that let them like do a Docker pull of all of, the stuff that they needed in a Docker run of it. Then we did have a developer who, at the time it was Fig. Docker acquired a startup called Orchard and like renamed Fig to Docker Compose, which just, it's the same thing, a lot more typing. But this allows you to kind of stand up a Docker environment by saying, stand up this container, link it to this container, give it this backend data store of this, whatever. You mentioned certificates. I would say even more important than certificates is all of the assets that like something would expect. What we did to solve, for example, that on people's local laptops, they wouldn't have RDS. So to give them, like the database, what we did was have Jenkins build a MySQL container, like build a Docker image that put MySQL and loaded a bunch of fixtures into it, so that if a developer did a Docker run of that, then they would be able to load up and look at, the site on, port 8080 on their box, and they would have what looked to be dramafever.com, which if you go to it and check it out, you will see it's totally a whole bunch of Korean soap opera. It's great stuff. And K-dramas, J-dramas, some telenovelas, Chinese language dramas, a lot of stuff from Taiwan. But anyway, so like a developer on their very first day would have the exact same development environment as everyone else, even front-end developers. And this front-end is where it gets trickier, because there's a lot of assumptions made in the tooling that like it's just being run on somebody's local. And like Bauer is notorious for this. You're like, you want me to just keep saying yes to things? It's like, I want to automate this. And but I did actually containerize all of our like Grunt and Bauer and NPM and all this stuff. And it's totally possible to run all of that stuff in a container and then have the developers not have to worry about what's on their local. Because that's just having to sync up your local environments is a non-trivial problem. And having that, like for the developers who are developing in Python, for example, we would have all the Python wheels on the Jenkins server, and then do a base build of what that Docker image should look like, and load all those wheels into it. And then all of the other Docker builds that we would do, like in the CI process, instead of saying from, Ubuntu 14.04 or whatever, we would say from base. So like that initial base build was already built, and then it would make the, further builds after it like that much faster. And as long as somebody had like done a Docker pull at some point of, the current dev, that would come with the way Docker works. It would come with the caching layers of like base. So that way people could still do a Docker build themselves if they wanted to, but they would be able to start from and also get back to the exact same place as everyone else. So, yeah. I feel like this was more Docker heavy than I intended it to be, but Docker is great. Keep in mind, containers are not the only thing. Containers are very, very useful, and they're a piece of your entire puzzle that includes things like schedulers and historics and circuit breakers, and health checks. And when you're building your platform, you have to think about all those things. So, all right, I'm out of time. Thank you very much.